Good morning, learners. Welcome to yet another example of conjugate acid-base pairs. A question will come to ask you to write down the conjugate acid-base pairs from a given chemical equation. All right, so for example, in this example, we are asked to identify conjugate acid-base pairs in this equation, all right, where we have a water molecule, water, reacting with a carbonic acid, all right, to form hydronium ion and a carbonate. Remember that an acid-base pair differs, an acid and its conjugate will only differ by a hydrogen, all right? Similarly, a base and its conjugate will only differ with a hydrogen or by a hydrogen. So in the given equation, you simply look for species that are similar, but they only differ by a hydrogen atom. For example, if you look at water, H2O, and the hydronium ion, H3O plus, these molecules are basically the same, but they only differ by a hydrogen. Take note that hydronium ion has 3 hydrogen atoms, while water has 2 hydrogen atoms. That means these two are acid-base conjugate acid-base pair. They form a conjugate acid-base pair. How can you tell that the given species are conjugate acid-base pairs? Just look at their number of hydrogen atoms. All right, take note that the rest of the atoms are basically the same. The oxygen atoms are present in each one of them, but their difference is on the number of hydrogen atoms. Therefore, in this case, water and the hydronium ion will form a conjugate acid-base pair. The two are a pair, the conjugate acid-base pairs. Similarly, if you look at the molecules HCO minus 3 minus and the CO3 2 minus, these molecules are also the same, but they differ with a hydrogen atom. This one has 1 hydrogen, while this one here does not have a hydrogen. Therefore, these two will also form another conjugate acid-base pair. All right, so let us see if you have understood this, if you can do the same for these examples. All right, in this first example, we have HC2H3O2, and on the other side, all right, on the other side. So for the time being, this is behaving like an acid, donating a hydrogen to water, so that water becomes a hydronium ion. So once this hydrogen is released or donated, the result is this species here, which does not have a hydrogen ion on it. Alright, therefore, the conjugate acid-base pairs for this particular one are going to be HC2H3O2 and C2H3O2 minus, so that's the first one. They only differ with a hydrogen atom. All right. In the same way, H3O plus and the H2O will also form another conjugate acid-base pair. Remember that the acid part is listed first, and then the base is listed at the end. All right, so these are the two conjugate acid-base pairs which are needed from this example C. All right, let's look at D. So you identify the species that differ only with hydrogen. All right. If you look at hydrogen sulfide, this one here, and the monohydrogen sulfide, these two also differ with hydrogen. So this one has two hydrogen atoms, this one has only one. All right, so therefore the conjugate acid-base pair will be H2S stroke HS minus. All right, that's the first one. Take note that they only differ by one hydrogen atom. In the same way, the other one, we shall have H. This one is, since this one is a base, therefore the acid will be the hydronium ion. So the conjugate pair is going to be H3O positive stroke H2O. Take note that the molecules are the same, but they only differ with a hydrogen atom. The one that has more hydrogen is listed first. All right, for example, here we listed this one first. H2S has more hydrogen than HS. So in this case, this one is an acid. This is a conjugate base. All right, a conjugate base. So always start by listing the species that has the most hydrogen. If you go back to the previous example, notice that we listed water and the hydronium ion. So when writing this, you have to say H3O plus stroke H2O. And the other one will be HCO minus stroke CO32 minus. So make sure that the one that has the most hydrogen is listed first. Remember, we are writing down acid-base pairs, conjugate acid-base pairs. So the acid is mentioned first. So this is an acid, this is a base. Right? Here it is behaving as an acid if you consider the reverse direction. Similarly, here is an acid, this is a base. All right, so that's very important to note. My name once again is Mr. Pochilolo. In case you have just joined us, don't forget to subscribe to the channel so that every time a new video is listed, you are the first one to know. All right, let's look at E, example E. All right, so here we have this species and this one here. They only differ with or by a hydrogen atom. So there's one hydrogen here and there's none on this one. So in this case, the conjugate acid base pair will be HSO3 minus stroke SO3 2 minus. Look at the way we are writing this. We start with the one that has the most number of hydrogen, and then the one with less or fewer hydrogen atoms is written second. The other one is, this is our acid, and this is our base. So we shall have H3O plus stroke H2O. So these are the conjugate acid base pairs. Make sure you go through these quite a number of times so that you master the technique. All right, let's consider F. For F, we have this one, NH3, which is ammonia, and then we have ammonium. So ammonium has the most hydrogen atoms, so we shall have NH4 stroke, don't forget a plus, stroke NH3. All right, so the one that has fewer hydrogen atoms is listed at the end. All right, similarly, this one is behaving like an acid. All right, so you list that as H2O stroke OH minus. Take note, H2O, which is water, has 2 hydrogen atoms, while this one here has only 1. So the conjugate acid pairs will be listed as shown. All right. And lastly, or G, we have hydrogen fluoride, HF, and the F. So HF has 1 hydrogen, while this one has none. That means the pair will be HF stroke F minus, stroke minus, F minus. Similarly here, this has the most hydrogen atoms. It has 2 actually. This one has only 1. That means the pair will be H2SO3 stroke HSO3, like that. And lastly, we have this one. This one has 1 hydrogen, this one has none. So the pair therefore will be HNO2 stroke NO2 minus. The other one will be, this one has the most hydrogen, therefore it will come first. So we have H2S stroke HS minus. All right, so these are just additional problems for you to master the writing down of conjugate acid base pairs. Please, in case you have missed something, don't hesitate to come back so that you can leave a comment for me to explain. It will give me pleasure to do that, to rectify what I might not have explained properly. All right, so we continue looking at another aspect of acids and bases. which is called strength or weakness of acids and bases. So we are going to define strength of an acid or base. The strength of an acid or a base is the ability of an acid or base to break down into ions in water. Okay, to break down into ions in water in a solution. The strength of an acid or a base is the ability of the acid or base to break down into ions in water. So the breaking down of an acid or base into ions in solution is called dissociation. Alright, so we can therefore define strength as the ability of an acid or base to ionize in a solution. To ionize simply means to form ions in water by an acid, is an acid or a base. So strong acids and bases ionize completely in a solution. When added to water, they are going to completely form ions. They will separate out into ions. So take note, we are saying the strength of an acid or a base is the ability of an acid or base to ionize in a solution. So strong acids and bases will ionize completely. On the other hand, weak acids and bases will ionize partially in water. All right, very important point to take note. So let's look at some examples just to illustrate a point. Look at the following equations. The left-hand side of each equation shows the formula for an acid containing hydrogen and other atoms. The right-hand side shows you the hydrogen ions fully separated from the other types of ions. That is what a strong acid can do. All right, so we are saying HCl, which is made up of hydrogen ions and chloride ions, when added to water, is going to separate. So the hydrogen ions and the chloride ions are going to separate out. So as before, the hydrogen will simply be added to water to form a hydronium ion, and the chloride ion is completely free from the hydrogen which was attached to it. Therefore, HCl is a strong acid. Another example is nitric acid, NH3. Nitric acid, NH3, has a hydrogen ion. It has hydrogen ion and the nitrate ion. Nitrate is NO3 minus. All right, so what's going to happen? The hydrogen will be donated to water to form a hydronium ion, and the nitrate is going to be separated completely from the hydrogen. Therefore, nitric acid is also a strong acid. A strong acid shall always separate out. Its ions are going to dissociate completely. Therefore, examples of strong acids are hydrochloric acid, HCl, nitric acid, NHO3, as well as hydrogen iodide is also going to separate out into its ions. Hydrogen iodide has hydrogen ions and the iodide ion. So what's going to happen when mixed with water? The hydrogen ion will be gained by water to form a hydronium ion, and the iodide ion will be separated. So these are examples of strong acids. Strong acids completely ionize in solution. They ionize completely. Another way to rewrite the same equations is simply to split each acid into two ions. For example, we split the hydrochloric acid into hydrogen ions and the chloride ions. These are totally separated. Therefore, hydrochloric acid is a strong acid. What is a strong acid? It is one in which when mixed with water, it is going to completely separate out into its ions. So in this case, the hydrogen ions and the chloride ions separate completely in water, and these ions, by the way, they are free. They are freely moving around in the solution. Similarly, we can split nitric acid into hydrogen ions. So we have hydrogen ions and nitrate ions completely free from each other. Therefore, this is also a strong acid. Nitric acid is also a strong acid. Similarly, hydrogen iodide is also hydrogen iodide is also going to separate out into hydrogen ions and the iodide ions. Therefore, this is also another example of a strong acid. So, in these equations, we have just shown that what has happened to the acid molecules in the water. All right? They have separated into ions, but the former equations are showing you how the ions have interacted with the water molecules, like here. In these examples, we've seen how the ions have interacted with the water. The interaction is that the hydrogen that is donated by each acid are gained by water. All right. That's very important to note. Okay, so for the time being, I would like us to stop here so that when we meet again, I'm sure to have us look at weak acids. Weak acids, then we look at strong bases and the weak bases later. Once again, my name is Mr. Pochilora, wishing you a beautiful Monday. We'll meet again later. Bye-bye for now.